Typically in the first day of the unit, there's quite a bit of new material and quite a bit of new things to understand as we introduce a new topic. So be sure to take a couple of minutes to digest this slide and everything that's on it. Particularly under the no column, those are all the things that I'll be talking about and just expecting that you know as we go through. And you can look at the do. We'll see examples of all the do, but it's the understand column that you really want to read through and try to think about all those ideas that are located in there that'll really help you understand how to construct these graphs. We'll begin by taking a look at our unit circle and the points that we labeled on our unit circle, all those ones and zeros and ones. Those are going to help us to understand the range of the sine function and the cosine function. And what I've listed here is just a basic sine function. You see some light blue numbers in there. We'll change those later, but for today we're just going to work with sine of theta and cosine of theta. And those are the things we worked with in the last unit, just basic sine of theta, basic cosine of theta. We talked all about that. Well, if we started the sine function at 0, our angle was down here at 0 degrees. Well, we said that the sine was equal to 0. We were looking at the y coordinate. So we'd start down here at 0, and then, trying to get that black line, there we go. As we move the angle up, as theta increased from 0, say it got here, well, if it started at 0, by the time we got to the top up here, it was equal to 1. Then by the time we got out to 180 degrees, it was back to 0. We came down and it was now at -1. We came back here, it was at 0 again. So what happened was we'd start at 0, go up to 1, down to 0, down to -1, and back up to 0. It never actually got any bigger than 1 before it came down to 0, and then it never actually got any smaller than -1 before it came back to 0. The same phenomenon took place when we were dealing with the sine function. We would start at 0 degrees, we'd go we'd start at 0 degrees and the cosine was 1. Take a look at that x-coordinate, it's 1. We got up here, the x-coordinate's now 0. By the time we get here, the x-coordinate is -1. By the time we get down to the bottom, the x-coordinate was 0 again, and then back to 1. So again, as we went around the circle, we had this idea that the cosine never did anything except fluctuate in between -1 and 1. That was true of both functions, maybe in different places, but the functions just took on values between -1 and 1. And for now, we're not going to talk about the tangent. We'll visit the tangent a little bit later. Let's take a look at these labels here. You notice that we made a big switch. In the last unit, we talked about 0, 90, 180, 270, and 360. In this unit, we're going to be using radian measure all around the graph. We'll start at 0. Pi will be right across from 0. That means 2 pi is if I get back to 0. So halfway between 0 and pi is pi over 2. Halfway between pi and 2 pi is 3 pi over 2. And the same thing on both graphs. Now let's see what we're going to do. We're actually going to take these circles and we're going to stretch them out horizontally. But perhaps I can best explain that to you by thinking about a Ferris wheel. This is the London Eye. And let's consider the fact that we can't get on the Ferris wheel halfway up, but we're going to call that the midline of the Ferris wheel. It's also going to be the midline of our graph. So we'll get on the Ferris wheel down here. We're going to take a ride around the Ferris wheel going in this direction. Let's talk about how much time we spend on the Ferris wheel, and let's figure out what our height will be after we've been on the wheel. So we get on the Ferris wheel at 0 time, and we begin by going up. We go up until we hit the midline. We're going up and to the right. So we keep going this way, but now things change a little bit. We're still going up, but now we're going to the left. And that won't match up perfectly with your graph, but there is a point of inflection here that you don't see. What's important is to understand that we keep going up until we get to the top of the circle. When we get to the top of the circle, what happens is we start going back down. And we'll go back down here until we hit the midline. Same thing on this side. And then we'll be going back until we're back at the bottom of the Ferris wheel. And we come back down to the bottom. Now, if you're on the London Eye, you get to go around twice, especially if you pay your money. So let's go back up until we hit the midline. We hit the midline here. We keep going up, a little bit of inflection, but we're still going up until we hit the top of the Ferris wheel. At the top of the Ferris wheel, we start coming down until we hit the midline, and then we continue to come down in a slightly different direction until we're back on the ground. So we've gone through 2 cycles of the Ferris wheel, twice around, and there's our graph. Let's talk about this whole idea of setting up the graph. Now, I'm not going to actually plot a sine or cosine on this graph. For now, what I just want to do is show you the things to consider when you're setting up your graph. You have to pay attention to the instructions. The instructions are going to tell you how to set up your x-axis. This says we want a graph in between 0 and 2 pi. So we've got to make sure that our x-axis scale lets us fit in between 0 and 2 pi. The y-axis will also be to scale, but it'll be the function itself that tells us about the y-axis, so we won't see that until we get to the next screen. We're going to have to plot the 5 important points on every cycle. The 5 important points will be the start, the end, the middle, the first quarter, and the last quarter. And so that'll be important to have those 5 dots in the exact places they belong. We can find where they are on the graph without any problem. The points in between, you've got a little bit more latitude with those. And then we're going to carefully sketch our curve. So again, we're working all in radians. So let's talk about what the graph looks like. Now there's a lot on this graph, and you won't need to put all of this on there. Some of it I have here just for your understanding of what's actually going on. We'll work with that for the first day, and then we'll ditch that idea. In between 0 and 90 degrees, or in between 0 and pi over 2, is our first quadrant. So I'm going to drag these 3 lines, green lines, to separate the quadrants. 0 to 90 is our first quadrant. That's the same as 0 to pi over 2, quadrant 1. Then we went from pi over 2 to pi, or 90 to 180, that's quadrant 2. We went from 180 to 270, or pi to 3 pi over 2, that's quadrant 3. And now we're going from 3 pi over 2, or 270 degrees, back to 360 degrees, or 2 pi. That represents quadrant 4. And I probably should have one more dotted green line in there for you. So what we've done is we've taken those 4 quadrants we saw in the circle, and now we've stretched them out along the x-axis. Quadrant 1, quadrant 2, quadrant 3, and quadrant 4. And so that will be your basic setup. You'll have the x-axis, you'll have 0 right here, that's still the origin, 0, 0. These numbers will come from your function. As I said here, these numbers come from your function, and we don't have a function yet, so you don't have to worry about where those numbers came from yet. We'll see that on the next slide. But that x-axis will always be labeled in radians. And you might notice that you might have some fraction work to do in here, but I'll do my best to make the fraction work easy for you. So let's get busy graphing one of these. And we're going to graph y equals the cosine of theta, just a basic trig function. Y equals the cosine of theta. I'm going to borrow my labelings from the last screen. So we need to know the 5 important points on the cosine of theta. Now, because there's an invisible 1 here, that's why I will appropriately put a 1 on my y-axis. And it doesn't matter how many blocks you use. I'm going to make it nice and big. 1, 2, 3, 4, 5, 6. I went up 7 blocks. If I went up 7 blocks for 1, 2, 4, 6, I've got to go down 7 blocks for -1. That only makes sense, otherwise it wouldn't be to scale. Okay, our 5 important points for a cosine. And I asked you on slide 1 to memorize 2 basic sketches. So what you want to know at this point is that a cosine curve will start up here, and it will also finish up here. Now both of those points are along number 1 on the y-axis. And I put the first point at 0, I put the last point at 2 pi. The middle point for a cosine has to come down to -1. Okay, so here's our midline. The x-axis is our midline, kind of like the midline of our London Eye. So start, finish, and middle. And now the first quarter will be right here on the x-axis. And the last quarter, or the third quarter, you could think of it that way, would be right here on the x-axis. Those are the 5 points. And you have to have those points in the exact proper location on your graph to get credit for it. At this point, we're ready to pick up our pencil because this is going to take some practice. We've got curvature in here. It's got to look like a function when we're done. It's got to look like it could pass a vertical line test. So we got a little bit of curvature. We're going to curve away from the first point and then bring it down to that first quarter mark. Keep coming down to the bottom, but we're going to curve when we get to the bottom. It's not a V. There are no sharp points here. So we got to make it look like it's got curve in it. We're going to come back up to the third quarter. And then again, we're going to go back up. We're going to meet that last point, but with a curve. We're not making V's. We're making smooth curves. So we want it to look like it's got curvature to it. It should look like there's curvature in here. It should look like there's curvature in here. Curvature down the bottom at that point. We don't really want any flat spots. It doesn't have to be perfect. You want a reasonable attempt. We don't really want any flat spots from side to side. We don't want any flat spots up and down. We want to make sure this thing looks like it could pass a vertical line test, and that does. So a couple of questions we'll answer. First of all, as x increases from 0 to pi over 2, well, we're looking at 0 to pi over 2. This function is now decreasing. That blue curve is coming down as we read from 0 to pi over 2. We're going left to right. So we're going to call that a decrease in the y. Let's move on. It says as x increases from pi over 2 to pi. Well, now we're going from pi over 2 to pi. Again, we're still decreasing in that zone, so I'm going to write decrease. Next question, as x increases from pi to 3 pi over 2. So we start at pi, and we're going to 3 pi over 2. We're talking about quadrant 3 here. And in quadrant 3, this function is increasing. So I'm going to write the word increasing in here. And now in quadrant 4, it's going to ask us 3 pi over 2 to 2 pi, which is the same as quadrant 4. Whoops, get that back up for you. Looks like it's increasing in quadrant 4, so we'll write increasing here. And notice that this entire function exists in between 1 and minus 1. There are no y values bigger than 1. There are no y values smaller than negative 1. Let's see what that last question is asking us. Got a couple of questions down there. It says, what quadrant is the cosine positive? Well, you should already be able to answer that question, but let's do it from this graph. Wherever that blue curve is above the x-axis, the function is positive. It's above the x-axis in quadrant 1. It's above the x-axis in quadrant 4. So that's where it's positive. Where is the cosine negative? Well, it's below the x-axis in quadrant 2, and it's below the x-axis in quadrant 3. So that's where we'd say it's negative. And then looking at some other questions down there, and we're not going to have to answer this for today. I'm going to delete that. It shouldn't be there. But let's take a look at that question. What is the maximum value for y equals the cosine of x? Well, the maximum value is the highest point the blue curve attains on the graph, and our maximum value here is equal to 1. The minimum value would be the lowest point that blue curve attains on the graph, and the lowest point would be a negative 1. Okay, go back and revisit that if you'd like. Otherwise, I'm going to move on to the sine function. Okay, sine function. Let's graph a basic sine function. Again, an invisible 1 in here, an invisible 1 in here. This is what we worked with in the last unit. Let's talk about the sine function and its 5 important points. Well, the start of the sine function is right at 0, 0. The end of the sine function is right at 2 pi. The middle of the sine function is right at pi. A quarter of the way, and again I'm going to mark off my 1 and my minus 1, and I'm using that invisible 1, or this invisible 1, in order to do that. We'll talk more about that tomorrow. 1, 2, 3, 4, 5, 6, 7 blocks up for a 1, which means 2, 4, 6, 7 blocks down for a minus 1. And let's continue to sketch. Start point, end point, middle. The quarter point is up at 1. And the third quarter point is down at minus 1. So there are your 5 important points that you need to graph for a sine curve. And again, when we do this is where you should pick up a pencil, because it takes a little bit of practice to get this, and I'm not going to do a perfect job with the pen that I have in my hand. I'm going to show curvature going up to this point here, curvature at the top. Don't want anything to look straight, and there are no straight points in any of these. And then down to the middle. And now I'm going to repeat the whole thing, but it's going to be headed down and then back up. So we're going down to down to this point down here, a little bit of a curve down there as much as you can muster, back up to 2 pi. And so that should resemble your basic sketch of a sine curve. And I'm going to fix a little bit in here. Make that look a little bit smoother. Remember, it's a function, so it should look like it could pass a function test, a vertical line test. There are no flat spots. I tend to make a little bit of a flat spot coming off the curve here. You want to do your best to avoid that happening. Okay, so we've got our basic sine curve drawn. Now we can answer a few questions about the sine curve. And they're going to be the same types of questions you just saw. In quadrant 1, which is in between 0 and pi over 2, my sine curve is increasing. In quadrant 2, which is between pi over 2 and pi, my sine curve is decreasing. So the answer to the first question is increasing. Answer to this question is decreasing. You can probably guess I'm going to ask you about quadrant 3. Quadrant 3, it's still decreasing, it's still going down. And finally in quadrant 4, it's increasing, going up. So that would be the answer to my next 2 questions in there. For the third quadrant, between pi and 3 pi over 2, we are decreasing. And for my last quadrant, which is, I keep trying to move this and I'm putting red lines on the screen instead. In the last quadrant, quadrant 4, we are increasing. We can ask the same kinds of questions about what's going on with which quadrant. In which quadrants is a sign positive? Well, you did this in the last unit, so you ought to be able to answer that question without the graphs, but it's very easy to read from the graph. Sign is positive wherever it's above the x-axis. So the answer here, you've probably guessed, is quadrant 1 and quadrant 2. Where is the sign negative? Sign is negative below the x-axis. That's quadrant 3 and quadrant 4. A little bit easier perhaps to figure that out than we did from the unit circle and looking at the plus minuses. Okay, last question down here, and again we're going to not worry about this red typing down here. I'm going to we'll take care of that on another day. But let's take a look at that last question down here, which asks us for maximum value of sine and minimum value of sine. In other words, what's the highest point on this red curve for the y? That's equal to 1. That's the maximum. Lowest point on the red curve is equal to a -1. We'll call that the minimum. One last piece of information that I want to share with you in this video is the whole idea of a period. And the definition of the period, this is something you're expected to know. The period of the function is wherever the first cycle ends. So we can look at the picture of the graph and we can figure out where the first cycle ends. A basic sine curve, and here's these sketches that I showed you on that first slide under the no are going to become very important. A basic sine curve looks like that. That's actually one complete cycle. A basic cosine curve looks like this. That's one complete cycle. So we have to figure out where the first complete cycle ends. And if you follow the path along this red sine curve here, we'll keep going until we finish one complete cycle. Looks like it ends right here. So the period for this function that's been drawn, the period is equal to pi. That's where the first curve ends. Now this is a cosine curve on the right. I know that because it's starting up here, it's not starting down at 0, 0, and that's one of the important characteristics. Sine curve starts at 0, 0, cosine curve starts elsewhere. This one's starting elsewhere. So this is a cosine curve. Now if you look at the graph and you compare it to a basic cosine curve, I'm only seeing half of that cosine curve. So I'm going to have to guess if it's 2 pi where it's halfway. If I were to extend it, the question is where would it end? If I was doing this all to scale, the answer is it would end at 4 pi. So the period of this one is equal to 4 pi. Tomorrow in class we'll get practice with sketching these and laying out our axes appropriately.